everybody. In this video, we will be solving LeetCode problem 136, single number, and we will be using the UMPIRE method that is recommended to be used in interviews. And the steps are understand, match, plan, prototype, pseudocode, implement, review, and evaluate. So the first one is to understand. So we are going to read the question and make sure that we completely know what the output should be. So given a non-empty array of integers, every element appears twice except for one. Find that single one. So there are some examples over here. There are two 2's and a single one, and the 1 is returned. And over here we have a 4 and two 1's as well as two 2's, and the 4 is what is returned. So over here it says that your algorithm should have a linear runtime complexity. I match it with a data structure or an algorithm I'm familiar with, and the one that comes to mind are dictionaries in Python. So dictionaries in Python could be utilized for a linear runtime. So now we have to plan and prototype, or start thinking about how will we approach this problem. So we can iterate through the list. So this is all going to be pseudocode. We're going to iterate through the list for num and num. We're going to add to a dictionary if it's not already in there. If it's in there, if the value, let's say if num is in the dictionary, we'll remove it. Move it. And at the end, our dictionary should have a single value, so we'll get the keys and we'll index the keys. So that's the plan to solve this problem. So now we can begin implementing. We're going to have a dictionary called visited, and we're going to loop through the num for num and nums. We're going to see if num is in visited. So if it's in visited, then we want to remove it from visited. So we're going to say del visited, and then we're going to give it a num. And then else, so if it's not in visited, then we want to add it in there. We'll just say visited num equals 1. So at the end, we're going to have visited, and then we'll get the keys, and then we'll convert this into a list, and we'll index 0. Now that we have completed the implementation, we must review our code to make sure that our code is running as expected. So we have a visited dictionary. We iterate through the nums. If the num is in visited, we remove it. Else, we add it in. And then by the end of it, our loop will have removed all the duplicates, and we will be left with one value left in the visited dictionary. We'll get the key, which will be our num, and then we'll index the only element in the dictionary, and that'll be our return value. So let's go through some examples. So our list is 2, 2, 1, and with this algorithm, initially it's going to be empty, visited is going to be empty, and then it's going to be 2, and 2 is not yet in the dictionary, so it'll be added, and then it'll continue to the next 2, in which 2 is already in the dictionary, so it'll be deleted. And then finally 1 will be added, and the list ends. So the loop ends, and we return it. So I think this is going to be working correctly, and we have an error in the spelling. We're going to run that again, and our output is as expected. As for edge cases, we don't have to check if it's empty or not, and there will be a single one. And now it's time to evaluate. So we have one for loop, and in this for loop, it's adding an element to a dictionary, which is O of 1, looking up to see if that item is in the dictionary, which is also O of 1. This solution does satisfy the requirement of it being a linear runtime complexity, and we have finished the umpire method. And as you go through your interview and you've finished all these steps, your interviewer might ask you to consider the problem in a different perspective and could ask a follow-up question. And over here we see that the follow-up is, could you implement this without using any extra memory? So we won't be going over that today. However, if you would like me to go over it, please let me know in the comments and I will get to doing that. And this is it for this video. Thank you.